All right, quiz 2 solutions for math 243. In this problem, instead of giving you data explicitly, what I do is I give you a stem and leaf plot here, and I test your ability to read this stem and leaf plot and come up with the data on your own. What are we talking about? Oh, this is eating chips. Eating chips during a football game for 15 adult males. Eating Juanita's chips. I like Juanita's chips, so I threw that into the problem. Whatever, doesn't matter. First thing is just prove that you know how to read a stem and leaf plot. So you have this stem and leaf plot here, and this little legend on the bottom, and you're supposed to be able to read it. The way a stem and leaf plot works is the last digit in the number is the leaf, and all other numbers make the stem. So this 5 right here is a leaf that goes with the stem of 0. So 0, 5, in other words, just the number 5, is the observation represented by this. This 2 right here represents a 12, not a 2. Why? Because it's on the row where the stem is a 2. So the leaf is, did I say that right? No, on the row where the stem is a 1. So the leaf is a 2, the stem is a 1, the last digit is a 2, all other digits are 1. What I'm saying is you got a 12. This 5 represents a 15. On this row, the 2 zeros both represent a 20, 24, 25, 28. So I got 2 20s, a 24, a 25, and a 28. Similarly, I have a 30 and a 35 in the next row, and then a 49 in the row after that. And then you get down here, and this a lot of people get confused here. What's this mean? It doesn't mean anything. There's no observations. There are no leaves that correspond with the stem of 5, so I leave this blank. You might wonder, why do you even write the stem of 5 if you don't have any leaves corresponding with the 5? It's so that we can still see the shape out of these things. Right? If you're making a histogram and you didn't have any observations in the 50s, you wouldn't get rid of that on your x-axis. You just wouldn't have a bar there. That's all. You still want these spaced out appropriately, so you still got to show these as blank stems. List the stem, no leaves corresponding. Then I got a 62, 75, and a 99 for this guy, and this guy. And then finally down here, this 0 corresponds with the stem of 12. So the last digit's a 0, the remaining digits are 1, 2. So the number I get is 120. So here's my stem and leaf plot, not stem and leaf pot. Whatever. This is the data that I got from it. Next, I'm asked to calculate the mean, the median, the standard deviation, and the interquartile range. Some of those you might be able to, or at least one of them, you could figure out just by kind of looking at the data. But it'll make your life easier to use one variable statistics on your calculator. And for some of them, like standard deviation, it would be a mess. I haven't even taught you how to calculate it without a calculator. So to calculate those things, first you got to put your data into a list. So stat and then edit and type it into a list. I did that before I started the video, so I don't want to have you watch me type numbers into a list. But in L2 here, I believe I have all these observations. Then you hit stat again and go over to the calc menu because you want to calculate stuff. Namely, you want to calculate one variable statistics on that data, which I put in L2. You go down and calculate. When you hit calculate, it's going to spit out a bunch of stuff, and it's up to you to be able to read this stuff to understand that the mean, the symbol for that is X bar. So I said round to 2 decimal places, so I guess it would be 41.27 because you come out here to 2 decimal places and you look one spot to the right of this guy. And since this is 5 or greater, you increase this by 1. Had this been 4 or less, you would have left that alone. The median is further down in this output. There it is right there. It's 28. What else did I ask for? Standard deviation. I'll abbreviate that because I'm lazy. I mean efficient. Is careful here. It's this S here. It's not this sigma. It'll never be this sigma. Sigma is the symbol that we use for the population standard deviation, something we will never try to estimate or calculate in this class. It's S that you're always looking for. The sample standard deviation, 33.63, if I'm rounding appropriately there. And then the interquartile range, I'm going to abbreviate that as well. My calculator doesn't tell me explicitly, but I know that that's Q3 minus Q1. Maybe you know that that's Q3 minus Q1. And Q3 is 62 and Q1 is 20. So all I got to do is subtract those two numbers. If you subtract those two numbers, you get 42. You don't got to write all this. I'm just writing this for the sake of solution so students can kind of follow, see where this is all coming from. Mean, median, standard deviation, interquartile range of this data. Round to 2 decimal places where applicable. I guess that's that. Part C, determine if any of the observations are outliers by calculating upper and lower fences. Note I said by calculating upper and lower fences because if I didn't, you'd have options. You could either calculate upper and lower fences, or you could just go to your box plot and take a look at it. But since I said to calculate them, I guess we should calculate them. We need a formula for the lower fence. It's Q1 minus 1.5 times the interquartile range. You also need a formula for the upper fence. It's Q3 plus 1.5 times your interquartile range. And I think we've already talked about Q1, Q3, and the interquartile range because we've got the interquartile range up here and Q3 and Q1 here and here. So for Q1, it's 20 minus 1.5 times that 42. You can do that on a calculator if you want. 1.5 times 42 is what, 63? And 20 minus 63 is negative 43. Yeah, I'm just showing off. Q3 is 62. And then to that, I want to add 1.5. Showing off, but if I screw one of these up, I'm going to feel like an idiot. Whatever. 1.5 times 42, which is 63. 63 and 62 is 125. These are my upper and lower fences. Determine if there are any outliers. So no outliers. Because all of my observations are in between negative 43 and 125. In other words, there's nothing less than negative 43 nor greater than 125. Create a histogram of the data below. Maybe before I do that, I'm going to show a way you could check your answer there. You certainly do not have to do this. But if you go under stat plots and then make a box plot real quick, grab this fourth one and tell it you want a box plot of your data, which I put mine in L2. You don't have to worry about drawing it or sketching the axes or anything. If you just hit zoom stat, the 9th thing on the list is zoom stat, gives you this box plot. If you look at this box plot, you'll note that there's no outliers. Oh, that makes me feel a little bit better about this answer that I came up with here. Don't have to do that, just advice. Create a histogram of the data below. Have your smallest bin track observations that are at least 0 but less than 20. Sketch that histogram below. Fine. My histogram, it's a two-dimensional graph. On the x-axis, I want to depict my bin. So here's 0, here's 20. If the first bin goes from 0 to 20, the next one goes 20 to 40, 40 to 60, 60 to 80, 80 to 100. When can I stop? Well, if we go back to our data, the largest observation was 120. Be careful, I was being kind of a jerk here. You might think you can stop at 120, but you can't. Because that 120 will not go in the 100 to the 120 bin. Because whenever we have ties, we always put them in the next higher bin. So it'll actually go into the 120 to 140 bin. So I have to go all the way out here to 140. I bet a lot of people stop at 120 and miss this last bin and only get like 2 out of 3 points or something like that. Then if I go back to my observations here, I could just go through and count how many are in each bin. I'm going to go ahead and have my calculator do that for me. So I don't know, maybe I'll put an axis over here. 1, 2, 3, 4, 5, 6, 7. That should be plenty. Make sure that that's plenty. So let's see, it's a 3-step process. Step 1, type your data into a list. I already did that. It's over here in L2. Step 2, program your appropriate stat plot. So I'll go into this first guy here and say, I don't want a box plot, I want a histogram, this third type. I want a histogram on my data L2, and frequency something I always leave alone. And then step 3 is where you program the window. You have to program the window when you're making your histogram. So first make sure that your cursor doesn't have alpha lock on. And then, if you press the window key here, you put in all the appropriate values. My x's go from 0 to 140, not 120. And my bins have a width of 20. It goes from 0 to 20, and 20 to 40, and 40 to 60. Each of these are 20 long. And then my y's, I think I told you 0, 10, and 1 will always work in this class. On my picture, I guess I went 0, 7, and 1. I only went up 7i here. But 7 or 10 or anything else, totally fine, doesn't matter. Once you got that all in there, just press the graph key. Bam, there's your histogram. You can trace, if it makes it easy for you to write things. My first bin here, there's 3 observations in it. My next bin, there's most of the observations. 7, wow, good thing I went up that high. Most of my observations over here on the left. I have a few in the next couple bins. See 1 here, 2 here, 1 here, sure. So a few observations kind of scattered over here. And they kind of keep coming out to this side. I have a bin with none, and then another bin Oh, right, that was that 120 to 140 we were talking about. This is my histogram. This histogram, does it ask for the shape? I think not till later. Guess I'm done at this stage. Usually it's a good idea to put a title on these things. But I'm not going to add one here because I don't want the grader to think that you had to have one and take off any points. If I had said, make sure that your axes are labeled or something like that, then you would want them. But here's kind of the minimum. And I'll say, could label axes if you want. It's not if you want. Fine, good enough. What about E? Oh, it's just checking that you could do that on a calculator, right? Because I think a lot of people might make this just by hand. And what I'm supposed to teach you is how to make this on a calculator. And if you make this on a calculator, you have to program the Windows screen. A minute ago, we did that, right? We said that the x-min was 0 because the x-min is always the left endpoint. That's weird looking. Equals? Sure. It's always the left endpoint of your smallest bin. The x-max is always the right endpoint of your largest bin, which would be 140. And your x scale is always the width of your bins, which are 20. Finally, what shape does the data appear to have and why? If you're staring at this guy and trying to figure out what shape it is, well, most of the observations are over on the left here, but you have this big long tail going out to the right. Those are the characteristics of a right-skewed distribution. Why? I don't know, because double hyphen's weird looking. Because most observations are on the left. And there's a tail to the right. And if you just said right skew because there's a tail to the right, that's fine too. Whatever. You understand the idea. That's all I'm looking for. So that is the end of this quiz.